So, hello everyone, welcome to this video. After the first video of the series, we had a look to the binomial formula. This was this video. Now we want to prove the binomial formula for any expansion of a term a plus b with the exponent of n with this form. The formula looks like this, and today we try to understand what's going on here. By the way, you don't have to understand what this sum sign, this is the sum sign. This is the sum sign means. I'm going to explain this in the video. So let's start with the binomial formula for a plus b cubed. This simplifies to a cubed plus 3a squared b plus 3ab squared plus b cubed. So there are two ways. The first way is to remember this formula, or the second way is to understand why this is true. Let's have a look to a plus b squared again and try to understand why a plus b squared is a squared plus 2ab plus b squared. Okay, so a plus b squared. You can simplify this. I hope this is standard knowledge. This should be an a. I'm sorry, this is a very ugly a. So if you have a plus b, so a plus b squared is nothing else than a plus b times a plus b. Okay? So now you can factor this out. I don't know if this is the correct English word, I'm sorry. So this comes to, you can say a times a and a times b and b times a plus b times b, which looks like this. A times a plus ab plus ba plus b squared. Okay, we already can write down. Maybe let's do this here. A squared plus. Now comes the part which is important. Why a lot of people seem to wonder why we have 2ab and not this form. I prepared a simple example. Let's have a look to 2 times 3 and 3 times 2. So let's actually replace a and b with numbers. So this is nothing else than 6 plus 6, and this is nothing else than 12. And let's see if we just take this term, 3 times 2, and with this gives us 6 times 2 equals 12. Okay? And this makes sense. So every time you have something like this, you just can say, okay, this is nothing else than 2 times this. Okay? If you think about this, this makes actually a lot of sense. So I just said this because it seems like still people are wondering why we have a 2ab. And then we've got plus b squared. Try to understand what we did there. Not just, oh, okay, we factor. And then instead, I'm sorry, this was German, if you wonder. Try to understand what we did with the, with a and b. This sounds stupid, but my goal for this video is that you don't watch the video till the end, but instead have a look to this formula and try to understand what we are doing there. Okay? That's the reason why you have a look, because if you really understand what we did there, this is extremely easy. But this takes some, maybe days to really get what's happening here. But don't worry, that's the reason why I'm here. So, let's get back to this example. General rule for the expansion of a plus bn. Okay? So, a plus bn. The binomial form for any exponent n is nothing else than the sum sign with n on the top and k equals 0. As I said, we are going to talk about what this means. N over k, binomial coefficient, times a n minus k times b times k. Okay? So, let's try to understand what is happening here. So, to understand what is happening is first let's just clarify the sum sign real quick. What this means. So imagine, I don't know if you, oh, there's some G missing. Imagine there is from coding, there's like a loop. What a loop basically means is there's a program and then it starts over. So it reaches a point X and then it starts from from a certain point. For example, let's see, we have Tom. Tom starts at point A and he walks to point B. Every time he walks from point A to point B, we have an infinite bookshelf. So he's taking one book out of this bookshelf, goes to B. If he comes to B, he returns straight to A. He does not take a book. So this means, So this means he goes from A to B, goes back from B to A, and then he starts over. And here he plus one book. So after one loop, so he goes to B and goes to A, he has plus one book. Then he goes again from A to B and from B to A, so he starts over, another book. So after two loops, he has 4 books. Okay? The same idea we are going to use for this sum sign. And what this basically says, we have the sum of k. K starts with 1. We could say k starts, for example, with 0, but let's stay at 1. If this is all confusing, it will be very clear in just a moment. Here at the top, we have our n, which is equal to 4. Okay? What our sum sign now says is we're taking the sum of k plus k plus k plus k. So, the crucial thing what now is going to happen, I'm so sorry. The same thing what is going to happen is the same thing like in our book example. For every time we add k, so this is our first one, this stays 1, okay? This is just k. But now he's going to take another book. So to the 1, we get 1, we add 1, so this is going to be 2. So for the next one, we're going to add another book, and then we get 3. And then we add another book, and this is 4, okay? So the end, this is nothing else than 10. What happened here? So k, let's say k1 plus k2 plus k3 plus k4. We start at 1, and for every new addition of a new k, so for k1 plus kn, okay, let's say kn plus 1. K in this case will add up to k. So k will just be increased by 1 in our example. I'm not trying to do this too complicated. So meaning if we have, for example, n equals to 5, we just add 5 here. Okay? So we just increased k by 1 for every time we finish with the operation. Let's say, for example, we've got times 3. We would make k 1 3 times 1 plus 3 times 2 and so on. Okay? What does this mean? Our n in this case just tells us how many times we have to cycle through. We have to run from A to B. So our loop, how often this loop is going to be, although loop is infinite, but you understand what I mean, and where our starting point is, and then we just increase by 1. If there is another definition, that's okay. then normally this has to be stated. So, now you understand the sum sign. Very nice. Let's have a look what is happening here. We've got an n up here. Let's make this clear. We've got an n up here. We start at k 0. This means the first thing we already can say is we know our first term has here in 0, as 0, and 0, I'm sorry. No, as 0, I'm stupid. Let's see, what does our n mean? Our n equals to our exponent. Yeah? We also see our n is here. Then we multiply this with a. We've got a here. A is nothing else than n a time with the exponent of n minus k. Okay? And b with the exponent of k. Okay? This means the more k increases, the smaller the exponent gets, and the bigger b gets. This is basically the thing it's going to be. However, please be careful of this term. Just because this gets bigger doesn't mean this has to be the biggest term. Although, normally it means this. We're going to see why. No, this is not wrong. This is completely wrong what I said there. Forget what I said there. But just understand the more k increases. Yeah, I'm sorry sometimes with English, like I can't express myself correctly. The more k increases, the bigger b gets. Okay? What is n over k? This is the binomial coefficient. So what this just means is nothing else than we are going to look the combination logic. So how many ways are there to combine n elements so we have n elements, and how many ways are there to combine with k? So you're going to understand what this means just in a bit. If you had stochastic, you will understand what this means. So let's write this the formula with an example. We've got let's start with our basic form, a plus b squared. So we know n equals to 2 because this is our exponent. K equals to 0. This is always defined. And a equals to a. So a n minus k. We can write 2 here, right? Because this is the formula. So we can already say 2 minus. I'm sorry. Oh, I forgot this one. So we can already say 2 over k times a is nothing else than a n minus k. So 2 minus k. And then we just say times bk. Oh, oops. So let's write this nice here again. So we've got 2. We've got k equals to 0. We've got 2k a 2 minus k times bk. So you can try to solve this for yourself, but I'm going to do this now. So the first operation is going to be 2k is equal to 0, so 2 over 0, a squared minus 0 and b 0. This is our first term. How many ways are there to combine 2 over 0? If you plug this in this formula, you will already know, okay, you have to be careful here, of course, because you can't divide by 0, but this is always 0 in this case, okay? Always 1, I'm sorry, this is always 1. So you already know this is 1 times a squared, b with the exponent of 0 is nothing else than 1, so 1, which is equals to a squared. Second term, no, we shouldn't forget, we make a new operation. This means our k increases by 1. So instead of 0, we now say 0 plus 1. So this is then 1, a squared minus 1, b1. As you see, this is equal to 2 over 1. How many ways are there? Of course, with the logic, there are two ways to combine. To combine one element. If you have, I'm so stupid sometimes. So let's say you have two elements, and maybe I'm going to explain this. There are two elements, and you want to know which combinations are there to combine one element. Yeah. One element. Let's say you've got A and B. Of course, there are just two options, A or B. Yeah, if you want to understand how many combinations is, if you want to have one element or one combination, so you want to have one element out of two elements, how many combinations are there? So A or B, so 2. So this means we've got 2 times A times B, which is equal to 2AB. And the third term, don't forget, because here we have to be careful. We set n equals to 2, but we rotate till our k hits 2. Okay, I hope I didn't set anything else before. So this is 2 over 2 times a minus this is going to be equal to 0, of course, and then b squared, which is equal to 2 times 2. How many, if we have element a, b, how many ways are there to combine those two elements? If you want to, so how many? So the order is regardless, but there are like one way, and this is a, b. Okay. I hope this is clear, but I think I explained this very bad. So we've got 1 a with the exponent of 0 is 1 b squared equals to b squared. Now we just add them all together. A squared plus 2ab plus b squared. Okay. Now your exercise is to think, why is this true? This will take some time, especially at the beginning. But try to go back, try to understand what we did there. As I said, let's go back to the formula. Everything here has a meaning. It has a meaning why we are taking the sum. It has a meaning why we are doing this, and it has a meaning why we're doing this. Nothing of this is just meaningless and it's just standing there for fun. Try to understand as much as possible. Start with the things that makes sense to you. Spoiler, small advice. I wouldn't start with understanding why we are taking, for example, BK. Start with the simple thing. Yeah, as I said, just have a look to this. What did we do here? And just think, why is this equal to this? And then it makes, for example, sense why we are taking a sum. Why could we take a sum if we have a look to those things, right? If we want to have the binomial formula. Okay. Try to understand, I mean, this is like the, here we try to combine things. So we search the number of combinations, try to understand what we are doing here. This is the thing where I said, try to understand what we are doing here. Okay, always do simple examples and try to understand why this is equal to this formula. Okay, and you can pause the video or you can continue watching, because I'm going to explain this just in a second, and then we're going to see us if you try to solve it by your own very soon. See ya, or till in a few seconds, I guess. So, hello, we are back. So, let's understand why this makes sense. The first idea which I want to point out is what we are doing here. If we have a plus b squared, and we're going with a plus b and a plus b, what we are doing here is we are looking for the combinations of the elements because of algebra. We do know that if we try with a plus b squared, if we try this and we expand this, really every part has to be combined So every part of this has to be combined with a part of this. And logically, if we combine every part of this with every part of this is the same. So every part of, let's say this is, oh my god, this is confusing. So let's make this again. A plus b, a plus b. Every part of this term is being combined with every part of this term. Therefore, every part of this term is being combined with every part of this term. You understand the logic? So, of course, if you heard binomial coefficient and you thought, oh, this is stochastics, so probabilities, you are right, because we are looking for combinations. So, firstly, let's have a look to the sum sign. There are n plus 1 terms total. Why does this make sense? So why are there first n plus 1 terms? Because we start with k equals 0. We don't start with k equals 1. Then there would be n terms. We start with k equals 0. If we want to reach, let's say, for example, n is equal to 3, of course, we need k1 plus k2. So this is 0, this is 1, k3, this is 2, and you see if k should reach 3, we would need another term. Okay? As I said, why does this make sense? Here, combination. So first term. So this is in our binomial formula, we've got this, this, and this. So the first term, let's make maybe, oh yeah, I could make this, a and this. A gets combined with a one time, and the result of this is a squared. B, on the other hand, gets combined with b also one time, so not on the other hand. So this means we've got b squared. And now we know that a and b gets together combined 2 times. This was not completely right what I did there, but actually, yeah, you understand what I mean. So a gets combined with b 2 times, and therefore we got 2ab. Okay? Because there are, logically, 2 combinations for a and b in this term, if we want to combine a and b. Again, we have this idea of combinations. If this is not clear what I mean with we have 2 combinations of a, b, it's getting clear, because this is the main idea behind this binomial formula, and this is the reason why it's actually pretty easy to understand. So, binomial coefficient n over k. How many ways to arrange k b's? So I'm sorry, this is very ugly. So k b's among n terms. Okay? If this doesn't make sense, as I said, we're going to explain this in the next slides. Let's take, for example, a plus b with the exponent of 3. Number to arrange a squared b is 3 over 1 equals 2. What is 3 over 1? Correctly, 3. Okay? Why does this make sense? Okay, we see we have got a squared. Let's, as I said, a plus b 3. You can check this by yourself. So this means we have a plus b. As I said, we're going to see the whole example just in a sec. We've got this. So the first way how to arrange a and a squared b is with a b. The second is with a b a, and the third is with b a a. Everything leads to this form: a squared b. A squared b, I don't know, a squared b. So this is the idea. As I said, combination. We're looking how often can we combine a certain term. And since there is a correlation, we're going to see this correlation just a little bit better in the next examples between k and a and b. This makes sense. This might all seem a bit random to you, but believe me, it makes sense. Otherwise it wouldn't work. So, what does a with the exponent n minus k and b with the exponent of k mean? So, I'm sorry, this has to say a n minus k. How many times a is chosen in in the terms, okay? In the terms. I don't know what this should meant, but how often is A being chosen in each term, okay? So let's say, for example, as I said, we've got our standard binomial formula with n and k equals 0, and we get n over k. And now we are at k equals, let's say, 1. We know because of this. So we've got n minus k, and therefore we got with n equals to 2, 2 minus 1, and a is 1. So we are looking how many ways are there to combine one a term, exactly one a term, okay? And since we know, and this is very important, this is very important that you understand this, because I think this is the crucial idea behind this. In this example, it is not possible, it's algebraic not possible to combine more than 3 elements. You could try to, I don't know, try to simplify or factor it out, and maybe you get something weird, but I mean, you could work with minus, but in the end, if you all would simplify it and bring it to the same logic, there is no way that you can combine more than 2 elements at once. And yes, if we say 2 times AB, we still combine only 2 elements, okay? And this is the crucial idea. This means if we know that A 2 minus 1 is A1, and we seek for the combination, we know the other term in our example, we see we have n over with n equals to 2. This means we've got here in this case, because k equals to 1, we've got times b1, okay? And there, of course, there are 2 options, AB and BA. And that's the reason why we have 2 AB, okay? This is a crucial thing you have to understand if you talk about binomial formulas. And BK is the same idea as I just stated, okay? Because if we, for example, say we had 3 apples, we have 3 apples and 2 boats, and we looked for a way how to combine these. This is not one, but in the end we always want to have just forget this. No. This would be too confusing. Just think if you have like this form, okay, only you have to combine 2 at a time, exactly 2. There has always to be 2 elements which are going to be combined. Same thing with a plus b, and a plus b, okay? Only that there has always to be combined 3 things. Why? Because you have their multiplication. As I said, you can't form, you could try to transform it, this is possible, then you maybe have something like AA and therefore an A is other. I think this should be possible, but in the end, if you simplify this, you will always have 3 operations, at least as long as you don't use brackets. Example, and then we are at the end. I mean, we have a long video. I think we are going to 30 minutes. Oh, Jesus Christ, for the binomial formula. A plus 3 cubed. A plus b times a plus b times a plus b. So let's try to make it fast. Let's go fast with it. We choose we choose 0 b's. Since bk with k equals 0 is b with the exponent of 0 times 0 equals to 1. Okay, this means the only way to combine A, if we don't want to have a B, because this is the thing we say, if we have B times 0, this means we've got B equals 1. B So this means we don't want to have a B. The only way to combine A is if we make A. Okay, and this is equals to A3. So this is the only way. We remember this. There's only one combination, okay? In our things, as I said, you can say, okay, there are other combinations, but remember, we don't regardless of order, okay? And we have a look at the order, but AAE, okay? So of course it makes no inness. So if we say this is A1, A2, A3, we can say 3A1. This is the thing what I mean. So we don't have a look at the order with our A example. So 3 over A squared B. Okay, we have a look. 3, 1. Remember there's a correlation between K and A. There are always 3 elements which are being combined. So we have a look how often A squared can be combined. So 2 A's with 1 B can be combined. In this case, with K1, we know we have at least 1 B, and there are 3 ways: AAB, ABA, and BAA. Same thing with B, just with BBA, BAB, and ABB. Since through over 2, we just want to have 1A because A n minus K is equal to A3 minus 2 equals to A1. Same idea as with A. If we have a 3 over 3, we know we have A3 minus 3, which is equal to A0 and therefore 1. Oh, I already wrote this down here. So the research just for combinations with B, and therefore BBB is B times 3. So everything combined gives us 3 over 0, A3 plus 3 blah blah blah. And obviously what we get is A cubed plus 3A squared, B plus 3AB squared plus B cubed. Okay? So what can we conclude? If we combine terms with each other, we try to find combinations of the different parts. In this case, every part has to be combined. Okay? And that's it. I hope you you understand why this binomial formula works. And as I said, if you understood this once, if you understood this principle once, you gain so much. I know it's long and it takes some time to really get it. But if you understand this, you understand so much about the logic behind combinations and algebra. Okay? So thank you very much for watching. See you very, very soon. Don't forget to check out my blog. There are ChatGPT comments, not to this subject because this video is really just about the understanding. There's not a lot of practicing, but to the binomial formula as a whole. But you see the difference between the video before, where we actually just had like a look to the basic binomial formula, is massive. Okay, so if you don't understand what's going on here, it's completely okay. Okay? If you understand this video, this is everything that counts. See ya!